So ovarian cycle, it's more complicated than in males, okay? And I'm going to do both graphing and explaining the hormonal events at the same time. Okay, so what I'm going to do on this graph, I'm going to roughly, listen up, roughly plot 4 hormones. And as I am drawing the steps of the ovarian cycle. So it all starts in the hypothalamus, which produces gonadotropin-releasing hormone, which acts on the anterior pituitary gland, which produces luteinizing hormone and follicle-stimulating hormone, which act on ovaries. Okay? That makes sense. What is the function of follicle-stimulating hormone? Based on the name. Yeah, it stimulates follicular development, exactly. Okay? So here, we have follicular development, right? And the function of luteinizing hormone is to stimulate the release of estrogen and progesterone. Are you following me here? Like, look, what happens here is this. Estrogen has inhibitory properties. Estrogen is a lot like testosterone in terms of the function. Can you see that? We're good? So now let's try to kind of start plotting it. So, since estrogen is constantly inhibiting gonadotropins, I'm going to focus on gonadotropins, okay? Since estrogen constantly inhibiting gonadotropins, levels of gonadotropins, are they going to skyrocket? Probably not. If they're not skyrocketing, levels of estrogen, are they going to skyrocket? Probably not. So we can put it kind of in this perspective. So we've got LH, we'll talk about, and we've got FSH. And here I have estrogen. Progesterone isn't even coming into play. Progesterone is like, we're going to talk about what generates progesterone. Progesterone, we can kind of put it in the parentheses. We're good? Here's one little thing. You see this follicle? When follicle grows, follicle produces estrogen. And the bigger the follicle is, the more estrogen it produces. Does that make sense? So the amount of estrogen starts to rise. Like, more dramatically, so to say. Okay, we're good? Are we clear? And now something absolutely phenomenally cool happens. At certain threshold, and I am not familiar with the exact mechanism, I tried to look up the literature and couldn't find a definitive answer. At some certain threshold, the interaction between estrogen and luteinizing hormone, look at this. Instead of being negative feedback, becomes a positive feedback. Are you following me? So, estrogen starts to stimulate the release of luteinizing hormone. Luteinizing hormone stimulates the release of estrogen, which increases the amount of luteinizing hormone in response. Are you following me? For a short period of time. And that short period of time results in the spike of luteinizing hormone and the spike of estrogen. If you're curious about follicle stimulating, it also goes up. So this peak right here is called ovulation. Does that make sense? So the follicle ruptures and secondary oocyte is released. Does that make sense so far? Good? Now, what happens afterwards? So afterwards, the regulation immediately switches back to negative feedback. We're good so far? It's virtually impossible to draw it. Like, it's easier to explain in dynamic, like drawing the stuff. So since it switches back, levels of luteinizing hormone after the ovulation, they drop. Levels of FSH drop as well. And levels of estrogen, they decline too, you know. This is something cool happens. Look at this. What is left when oocyte ovulates? Behind oocyte, when follicle ruptures, right? Oocyte goes into the fallopian tubes. What is left behind is a body called corpus luteum. Yellow body. Does that make sense? And this corpus luteum starts producing substantial amounts of estrogen. And in addition to estrogen, massive amounts of progesterone. Okay? Okay, now let me put these things together. I'm going to go over this process and this schematic all together at the same time, okay? So at the start of the ovarian cycle, during so-called follicular phase, right here, you see normal negative feedback inhibition of gonadotropins by estrogen. Are you following me? Due to the growth of the follicle, the amount of estrogen increases and increases and increases until at some point, right in the beginning of ovulation, estrogen and luteinizing hormone exhibit positive feedback loop. Are we clear? Are we clear?
That's at the start of ovulation?
At start of ovulation, the negative feedback between estrogen and luteinizing hormone switches to positive. So increasing amount of estrogen results in the increasing amount of luteinizing hormone, which further stimulates estrogen, which further stimulates LH. More estrogen, more LH. Are we clear? At the peak, ovulation happens. Follicle ruptures and secondary oocyte hopefully goes into the fallopian tube. Does that make sense? Are we clear? Now, what happens next? The feedback mechanism switches back to negative, and the remnants of the follicle, so-called corpus luteum, start producing large amounts of estrogen and progesterone. Does that make sense to you? Good? So these large amounts of estrogen and progesterone suppress gonadotropins and suppress gonadotropin releasing hormone. So far we're good?
Is the corpus luteum left in
In the ovaries. It's left in the ovaries. Now, what happens after? Well, it generally depends on whether oocyte is fertilized or not. Now listen up. If oocyte is not fertilized, now look at the board behind me. If oocyte is not fertilized, then the levels of these two hormones, they go down because corpus luteum simply dies. Like it gets converted to corpus albicans and that's it. Does that make sense? So since you have no corpus luteum left, levels of the hormones decline. Now, look at this. I'm going to use estrogen as an example. Check this out. As levels of estrogen decline, what happens to the levels of gonadotropin releasing hormone? Estrogen goes down, GnRH goes up. Gonadotropins go up. Cycle starts over. We go back to square one. Does that make sense? Now, if it is fertilized, what happens next? If it's fertilized, corpus luteum will last for 2 to 3 months. And it will provide steady levels of estrogen and progesterone for the proper implantation and development of the embryo. Does that make sense? Now, a few words about the menstrual cycle. So, in menstrual cycle, here's what I want to highlight. So I'm going to draw sort of a thickness of the stratum functionalis. Okay, so this is like how thick it is. So, at the very beginning of the menstrual cycle, this is the time, so this is menses. Okay? Does that make sense? Now, this and this, check this out, they roughly correspond. Am I clear? Why menses happen? I mean, what's the exact mechanism? Remember there are two layers in endometrium, stratum functionalis and stratum basalis. Stratum basalis provides blood support, basically. It's where the blood vessels are for stratum functionalis. Does that make sense? So before menses, the blood vessels in stratum basalis, you probably should just look at me. Blood vessels in stratum basalis, they constrict and essentially suffocate stratum functionalis. Does that make sense? It dies. Then blood vessels dilate. There's a rush of blood, and blood literally washes away stratum functionalis. Make sense to you all? Good? Now, what happens? So, what happens immediately after the ovulation? So ovulation will be probably somewhere here. Look what happens. Estrogen levels increase, right? Okay. So this is menses, menstrual phase. Then, when estrogen levels increase, estrogen stimulates the regrowth of stratum functionalis. So this is your growth phase or proliferative phase. Okay? And when stratum functionalis gets fully restored, look, the thickness remains the same, right, over time. It enters the secretory phase. Secretory phase is governed by progesterone. Are you following me here? So progesterone stimulates the secretion at the stratum functionalis. If fertilization does not happen, listen, if fertilization doesn't happen, what happens to the levels of progesterone and estrogen? They fall down. That decline in hormones results in suffocation of stratum functionalis, menstruation, and this whole process starts over. Does that make sense? Clear? So, what if fertilization happens? Estrogen's high, progesterone's high, right? Stratum functionalis remains functional, so to say, and it is ready for the implantation of the fertilized egg. Are we clear? Okay. Good.